This video will demonstrate handling of whole substrates using tweezers and cassettes. First, let's talk about wafer handling tools. Here are the common types in our lab. Delrin is an inexpensive plastic that handles high stress without deforming. Delrin tweezers have a small grip area, so need to be used carefully. These should never be used for dipping samples into chemicals, especially oxidizing agents like piranha, as the Delrin will catch fire. Use Delrin tweezers to hold your wafer about 3 to 4 millimeters from the edge, enough to get a grip. Teflon tweezers are much more expensive but chemically inert. They do not grip well, so use them carefully so that your wafer does not slip. Use Teflon tweezers to hold your wafer about 3 to 4 millimeters from the edge, enough to get a grip. These metal tweezers are designed for handling flat substrates. They have a large, flat paddle to contact the back side of your wafer and teeth to grip the front side. The green tip is a Teflon coating to protect your sample from direct contact with metal. When picking up a sample, the paddle should be positioned on backside, with the back edge of the paddle touching the wafer edge. This places the teeth to grip properly on the front side. Note that the metal tweezers should not come into contact with corrosive chemicals. A vacuum wand holds your wafer using a vacuum port on the paddle. There is a switch on the handle to allow you to turn vacuum on and off in order to pick it up and release your sample. To use, place the vacuum paddle on the back side of your wafer, with the back edge of the paddle contacting the wafer edge. Then turn on the vacuum. The paddle must be flat against the wafer in order for the wand to pick up. Now let's talk about wafer cassettes or boats. Wafer cassettes are a convenient way to transport and store wafers. They come in a standard form factor that allows them to be used on equipment with automatic wafer handlers. Different types of cassettes are used for different applications throughout the lab. Ordinary plastic cassettes are used for storing wafers. These cassettes are lightweight. While convenient for storage, these cassettes are not stable to chemicals, so should not be used in processing. They will also off-gas low molecular weight materials, so wafers that are stored for an extended period of time in plastic cassettes may need to be re-cleaned. Teflon cassettes are inert to most chemicals, so are used at wet processing stations and may be heated up to 150 degrees C. Although they may look like ordinary plastic, they are much heavier. Note that Teflon absorbs chemicals over time, so this is one reason why each station has dedicated cassettes to ensure against cross-contamination. Teflon cassettes are soft and tend to flex. Metal cassettes are rigid, conductive, and heat-resistant, and so are often used with wafer handling equipment. Although these cassettes are all made of different materials and may appear to have different shapes, they all have a common form factor, as mentioned earlier. Note the notched slots, which will hold up to 25 wafers. Also note that there's an H-bar at the back of the boat. By convention, the backs of the wafers should face this H-bar, because this H-bar is used to position the boat on wafer handling equipment. And note the 2 pins on the right side and the 2 holes on the left side. These pins and holes allow you to align 2 cassettes for transferring wafers. For transferring wafers from one cassette to another using tweezers, here's what you will need. First, tweezers or a vacuum wand. Make sure they are the right kind for what you need to do, with respect to both the kind of material they are made of and the level of contamination appropriate for your application. You will also need an empty receiver cassette and the donor cassette containing your wafers. Place the cassettes next to each other with their H-bars facing the same direction. Position your tweezers to pick up your wafer 3 to 4 millimeters from the edge. Lift the wafer straight up and out of the cassette. Movement should be smooth and silent as possible. Avoid scraping your wafer along the sides, as this generates particles and can put stress on your wafer. Make sure to avoid hitting the front side of the wafer behind. Place the wafer into the receiver cassette. Movement should be smooth and scraping should be avoided. Make sure the wafer is not cross-slotted, as wafer handling equipment will not be able to pick wafers up. This also puts stress on your wafer. Best practice is to move wafers from the donor cassette from back to front to the receiver cassette from front to back, as this helps avoid scratching the front of the wafer being moved. It is also best practice if you place the cassettes so that you can avoid working over the wafers. This helps to minimize contamination. Here is an example of properly slotted wafers, with all the wafers lined up and parallel to each other. And here is an example of cross-slotted wafers. One can also transfer wafers from one cassette to another using the roll transfer method. This can be done to transfer many wafers at once. We will now demonstrate how this is done. First, obtain an empty receiver cassette. Make sure it is the appropriate kind and level of cleanliness needed for your process. Wearing clean vinyl gloves, place the receiver cassette upside down over the donor cassette. Make sure to fit the protruding pins into the alignment holes on both sides of the cassette. Firmly hold and lift both cassettes in both hands. Try not to flip the wafers, as the impact creates particles and can damage wafers under stress. Instead, gently tilt both cassettes so that your wafers roll from one cassette to the other. Your wafers have now been transferred. Wafers should not be touched with gloved hands, even clean vinyl gloves, which have plasticizer residue. Good, careful handling practices will help ensure wafers are undamaged and minimize the possibility of contamination, which could adversely affect device processing and performance.